All right, this video is going to go over geometric series, so let's go ahead and get started. The first thing I will say is don't forget about this equation down here. That was more for sequences, but we will need it for this section right here. But the main two equations you're going to use are up here at the top. So you have two of them. One of them is if they tell you when to stop, like here, they tell you to stop at 3, or here, they tell you to stop at 8. That would be this equation right here, all right? The other equation, this one, is when they don't tell you to stop. So they don't put a stop there, or they just tell you go to infinity on sigma notation. So keep that in mind when to use each one. That's very, very important. Now, in terms of what the letters represent, it's pretty self-explanatory. I have it labeled, but basically you have your start, you have your rate, and you have your number. And so like this first equation, this rate is going to be in both places here, top and bottom. And then over on this infinite series equation, you just have a start and a rate. So, all right, look at number 1. They want you to write it out and find the partial sum. All right, do not assume that this is your a sub 1. It is not. You have to go get a sub 1 by plugging in a 1 here for n. So if you do that, you get 3/4. And then if you do it again, if you plug in a 2, you'll get 3/16. And if you do it again, you plug in a 3, you'll get 3/64. So you can either add all these up by hand, or you can use the equation. I would use the equation. It would look like this. The sum of the first 3 is going to be the first term, which was 3/4, times 1 minus your rate. This is your rate, 1/4. And we should honestly put that in parentheses. And then it's to the power of n. Well, the n was 3. They told you stop at the third term. Over 1 minus your rate. Now, just be real careful when you enter this in the calculator. Personally, I like to do this right here, 1/4 to the power of 3. And then I do 1 minus my answer. And then I do the times 3/4 and then divided by 1 minus 1/4. So that's how I enter it in. Just, you cannot do, you cannot do 1 minus 1/4, then go to the power of 3, like 3/4 to the 3. If you do that, you've lost. So, all right, but anyways, you should get 63/64, or you can put 0.98. Some of them you can kind of see the fraction. Some of them you're just going to use a decimal. So that's how you do those first 4. Go get your first term by plugging in a 1, and then apply your rate over and over to fill this part out. And then in terms of, I'll just do another one real quick. Number 3, if you plug in a 1, you'll get your A1 as -1. And you know your rate is 3/2. So the equation you would use would look like this. The sum of the first 4 numbers, that's where they tell me to stop, is my first term times 1 minus my rate, but this rate is to the power of 4, that's my n, over 1 minus my rate. So that's what it would look like. Okay, moving right along. Of course, the computer freezes there. Okay, moving right along. Now they want you to find the specified sum. So it's pretty much the same thing that we were just doing. The thing is, they don't tell you the rate on all of these. So you have to go get the rate. So if you look here, you're timesing by 2 as you go left to right. So R is 2. Your first term is 5. And so you can just use that equation. It went, the sum of the first 8 numbers is my first term times 1 minus my rate to the power of n, which was 8, over 1 minus my rate. So if you punch this in correctly, you should get 1275. So that's how you're going to do the number 7 there. And really number 9. All right. Now number 11, you have to go get your first term. So if you plug a 1 in here, you would get 2. And then you know your R is 2. And then it's the same thing. So same thing here, plug in a 1. If you plug in a 1, you'll get A1 is 5. And your rate is 3/4. And then you can do the same thing. All right. Now, these are all infinite. So I'm not using that same equation. I'm using this equation. S equals A1 over 1 minus R. So all you need is the A1 and the R. So like, look at this one. To get your R, you do the second term divided by the first term. So this is negative 1/2. This is R. And so once you know that, you can just be like, okay, well, it's just S equals my first term divided by 1 minus R, which was negative 1/2. Now be careful on this, like whenever you get like 1 minus negatives, it joins together and becomes a plus. So it's really like 1 plus 1/2. You could even just type it straight into the calculator, like minus negative, and it'll do it for you. But anyways, if you punch all this in, you should get negative 2/3 for this one. So that's how you're going to do like the next one. Number 10, you're just doing that same equation, your first term, which was negative 1 over 1 minus your R, and just punch that in the calculator. Now these 12 and 14, you have to go get the first term by plugging in the 1 here. So if you plug in a 1, you would get 2. That's your first term here. And your R is 1/2, right? And so now you're just like, okay, S equals first term divided by 1 minus the rate. And so you'll get 4. All right, now I was just thinking about something. Look at number 8 and 14. These are what we call divergent. Means they don't have a sum. And the reason is because the rate is greater than 1. Greater than, they really call it the absolute value of the rate is greater than 1. So like here, your rate was 4. You can't do an infinite series, because if you think about it, these numbers are just getting bigger and bigger and bigger and bigger. It's going to add up to infinity and more. Like it doesn't make any sense. So you have to have a rate that's less than 1 in order to do the infinite series equation. I hope that made sense. So you would just write no sum. All right, moving on. Now they want you to write each of these in sigma notation. So go ahead and draw sigma. They give you the first term, so your bottom's n equals 1. They tell you either, or yeah, they're giving you the where to stop on all of these. So like this one, it's going to be a 6 up at the top. That's your finish line. And then the thing is, though, you need the equation, right? So here's A1. R was 2 here because you're just timesing by 2. So to get this equation, you just put A1 times R to the n minus 1. This right here. So you don't have to put that 1. I'm going to go ahead and put it, though. I'm going to show you one more of those. They're not that bad. Let's look at number 18. Sigma n equals 1. They want me to stop at 9. And then this equation, here's A1. My rate is negative 1/3. And so it's just A1 times the rate to the n minus 1. So that's all you have to do for those. Okay, let's look at the second page. now they're wanting us to do two infinite series, these two. So you're just going to use that same equation. And I'll do this one. So you have -6 over 1 minus r, which was -2/5. So if you do this right, you should get -30 over 7. Or you could have done it with your calculator and gotten a decimal. It would have been like -4.29. So that's how you're going to do those two. Now, these, you have to go find A1. They're not going to give you A1 for these. And so some of them, they'll give it to you as finite, some of them as infinite. So like what I mean by that is some of them stopped at 8, some of them didn't stop. They went all the way to infinity. So we're going to be using both equations here. Let's look at 21 first. Let's write out that equation. S of n equals A1 times 1 minus r to the n over 1 minus r. Okay, you know that n is 8 right here. You know S of 8 is 1020, and you know r. So plug in everything that you know. You knew S of n was 1020. You don't know A1. That's what we're looking for. 1 minus, you know your rate is 2, and you know your n is 8. So it would look like this. So the way I solve this is, I usually take care of this part first. This is -1. Now cancel it by timesing by -1 on both sides of the equation. So you got -1020 equals A1 times 1 minus 2 to the 8. We'll go get a value for 1 minus 2 to the 8. 1 minus 2 to the 8 is -255. And so now you can just go, okay, well, I'll just divide by -255. You get A1 is 4. So again, plug in everything you know, and then just go solve for A1. They're not that bad. All right, let's look at the infinite ones. You're going to be using the other equation. I'll do 24. All right, so the equation you're going to use is S equals A1 over 1 minus R. And so you know that the sum is 50-50. You don't know A1, and it's 1 minus 1/2. So really you have 50-50 equals A1 over 1/2. And so to cancel that 1/2, just times by 1/2 on both sides. And so you get 25/25 is your A1. All right, and then this last part, if they're asking me if it converges or diverges, really you just need to know it converges when the absolute value of the rate is less than 1. If you get the absolute value of the rate as greater than 1, it diverges, and you cannot, I guess greater than or equal to for diverges. It diverges and you cannot do an infinite series. So like look at 27 right here. The rate is 5/3. This is greater than 1. That means this diverges, which means no sum. You can't do it. But all the others, you have a rate that's less than 1. So basically, look at number 30, for example. Go get your rate, which here it's -1/3, and you know A1, and then just go plug it in. So S equals A1 over 1 minus your rate. And then just punch that in the calculator. You'll get 27/4, or 6.75. All right, and so that is geometric series. In my opinion, they're not as bad as arithmetic series, but they can still be kind of tricky. So hope this video helped.